So today we're going to talk about some application problems where a triangle is not a right triangle. So here's a word problem. So Joanna borrows some tools from a friend so that she can precisely, but not exactly, measure the corner space in her backyard to plant some vegetables. She wants to build a fence to prevent her dog from digging up the seeds that she plants. So Joanna returns the tools to her friend before making the most important measurement, the one that will give the length of the fence. So she decides that she can just use the Pythagorean theorem to find the length of the fence she needs. Is the Pythagorean theorem applicable in this situation? Explain. So here is what her backyard looks like. She did measure 100 units here, and she measured about 74.875 units on this side. Now the angle that forms with the two measurements she made was 95 degrees, and she gave us the measurement of the other two angles, and I guess this is the fence that she wants to make so that the dog doesn't get in. So can we find this length using the Pythagorean theorem? And of course, you guys know the answer. No, the corner of the backyard is obviously not a right triangle. It's very close to a right triangle, but we cannot find the exact measurement. But if we do the Pythagorean theorem, it will give us about approximate measurement, a good estimate, because since the 95 degrees is pretty close to 90 degrees. So how do we find the precise measurement of this third side? And considering that this is not a right triangle, we cannot use the trig ratio using this diagram as it is. So we're going to do something. We're going to draw something in the diagram. So how do you find the length of the third side when it's not a right triangle? So we did an example similar to this where it's an isosceles triangle. So it's actually the same concept. So what can we do to help Joanna figure out the length of the fence she needs? So the first thing you're going to do is draw an altitude where the 95 degrees happen. So you're going to draw an altitude and it's going to look like that. And when you draw in an altitude, you know that this is going to form a right triangle, right angle. And these two segments you need to add to find the whole distance of this segment. So we're going to label this. You can label this as any variable you want, but I label it as x and y. So you're going to figure out what this length is, x, and this is a right triangle. So you're going to find the length of x using this right triangle. So which trig function do you think we can use to figure out x? So if you notice, this is 35 degrees and this x is the adjacent and the 100 is the hypotenuse. So we have adjacent, hypotenuse, so we can use cosine. So we're going to use cosine of 35. We also need to find this length y, and we have the 50 degrees here. And this happens to be also the adjacent, and this 74.875 is the hypotenuse, so we can also use cosine in this case. So we can figure out the ratio of cosine of 35 and cosine of 50 and plug in the ratios using SOHCAHTOA, so we're going to use CA. So cosine of 35 is going to be x over 100, cosine of 50 is going to be y over 74.875. So if we want to find the x and the y, take the cross product, and we're going to get that. Now, of course, if you put that in the calculator, it will give you the lengths, and again, decides the x is going to give you about 81.9152. The y value gives us about 48. And of course, we want to figure out the length of the whole fence. So if we add those together, we're going to get approximately 130 units.